All right, we're going to talk about how do we apply right triangle trigonometry to application problems. Before we do that, we need to talk about a couple of phrases that are often used in these problems: angle of elevation and angle of depression. So looking at this diagram here, angle 1 here, since it goes, we have this horizontal line drawn out from this airplane here, but this angle 1 sort of gets formed by going downward to this line, right? So since we're going downward from a horizontal, that's an angle of depression. And then let's take a look at angle 2. Now that angle is being formed by this horizontal from this person's eye level, but then it's the other side of the angle is upward from that horizontal. So that's an angle of elevation. All right. Angle 3, well, that's downward from the same horizontal from that person's eye level, but it's downward now, so that is an angle of depression. I'm just going to abbreviate here, use ditto marks. And then angle 4, well, that is being formed by this horizontal line being drawn from the sailboat, but the other side is up from it, upward, so that would be an angle of elevation. All right, so that's what those terms are referring to. Okay, so downward from a horizontal, angle of depression; upward from a horizontal, angle of elevation. Okay, let's take a look at number 9 here. It says an observer in an 80-foot tall watchtower spots a fire burning at an angle of depression. It's missing a word here. Angle of depression of 20 degrees. How far is the fire from the base of the tower? So I am not the greatest artist, but that's okay. You don't have to be with these problems. You can just draw, stick figures. That's what I'm gonna do. So here's my watchtower. All right, and so this person here, they're seeing a fire burning. So this is 80 feet. Okay, the height of the watchtower. And then they're seeing this fire burning, and it says it's at an angle of depression of 20 degrees. So that's referring to from their horizontal going out. This is 20 degrees. Okay. So it's asking basically, what is this here? Now we got to be a little careful because the 20 degrees here is actually not in the triangle, but we could identify another angle here. We know that if we're going to assume the watchtower is perfectly vertical, okay, if it was constructed correctly. So this would be a right angle, and also we'll have like a right angle here to the horizontal. So we know that if this is 20 degrees and then this whole thing is 90, well, that means this piece of it here, I'm going to get rid of the right angle now because that'll be in the way. This part of the angle right here is going to be 70 degrees. That's one thing we could do. You could also, there would be a way to think about parallel lines, and then this would be 20 degrees. Okay, either way you do it. So you can do this problem a couple different ways I could think of, but here's the way I'm going to do it. All right, so okay, we have this angle. We do need one angle measure in the triangle in order to use trig, and then we have one side length. That's enough to use trig. So let's think about what ratio we'll have to use here. We have the opposite side from the angle, the opposite leg, and then we also have the adjacent. So that means we're going to have to use the tangent formula. So tangent equals opposite over adjacent. Okay, and our angle is 70 degrees. The opposite is just x, and then adjacent is 80. And now what we do is multiply both sides by 80, and 80 times the tangent of 70 degrees is what x is going to be. I'm going to go ahead and write my answer over here after I put it in the calculator. So 80 times the tangent of 70 degrees, we get 219.8 approximately. Once again, I'm going to round the nearest tenth. That's not like we always do that, every single time, but I wasn't given much instruction here in the directions of how to round. So I just feel I want to indicate, hey, it's not a whole number, but I think more than a tenth would be probably overkill. But that's just kind of my opinion there. I'm not using any rules to determine that. Okay, so 219.8 feet would be our approximate distance there. Okay, and then I'm going to go ahead and do number 10. Number 10 is different. So a monument is 116 meters tall and casts a shadow of 196 meters. What is the angle of elevation of the sun? So we have some kind of monument here. I'm just going to draw a straight line. And then it casts a shadow of 196 meters. So basically 196 meters is the shadow. And then this is 116 meters tall. And we want to know what is the angle of elevation of the sun. And what that means, I mean, if you think about it here, the sun, which of course would be, millions of miles away, but still the angle here of the, with the tip of the shadow, that's the tip of the shadow formed by this imaginary line to the sun and the ground. That would be the angle of elevation, right, from the ground. Okay, so that's what that's referring to. So that's sort of our unknown. We'll call that theta. And let's see which ratio I would use. It's going to be tangent again. I have opposite and adjacent. Right, here's the right angle. Okay, so opposite and adjacent. So we're going to use tangent again. So tangent of theta equals 116, the opposite, over the adjacent 196. And then I need to take the inverse tangent of both sides. So basically I'll be left with this. And then I just need to put that in my calculator and see what that is. So inverse tangent, second tangent, 116 over 196, and I get 30.6 approximately. So the angle from the ground to this imaginary line up to the sun is going to be about 30.6 degrees.